GCSE Physics boosters, and this video is about atomic models, and that basically means how our model of the atom has evolved over time, over the last couple of thousand years. Here are some pictures of the people involved. How many of them do you recognize? Now, rocks can be ground down into smaller and smaller particles, eventually into dust. Now, is there a limit to how small these particles can be? Well, about 400 BC, a Greek philosopher. Now, the Greeks didn't really do experiments. They just kind of went around in groups and had big conversations and drank ouzo and ate kebabs and came up with clever things. And this guy, Democritus, came up with an idea that everything was made up of tiny little small particles that were so small you couldn't chop them in half. They were fundamental. Yeah, they were indivisible. Now, the Greek word for to slice is tomos, and so if you can't slice it, then it is atomic, and so that's where we get the word atoms from. So these tiny, indivisible particles called atoms, thanks to this guy here, Democritus. Now, in 1904, a guy called Thomson he did an experiment, and he discovered that you could take away tiny little negative particles away from atoms, and what you were left with was positive. And this basically means that atoms are made of positive and negative stuff. Tiny little particles which have a very, very small mass, which we call electrons. And when you take them away from atoms, you're left with positive stuff. Okay, so he came up with a new model of the atom called the Plum Pudding model. So imagine an atom is made of a very light, airy-fairy, positive-y, spongy stuff, and in it there are tiny little negative electrons. So this is our model of the atom, a spongy positive stuff with tiny negative electrons. And this explains why if you take away an electron, then what you're left with is positive, because there's more positive charge there. And this model fitted the evidence, but not for long, because some new evidence came along. Now, a guy called Ernest Rutherford, who was working in Manchester at the time, Manchester University, and his friend Marie Curie gave him a piece of radium. Now, radium emits alpha particles, and it was known that alpha particles are very, very dense, positively charged, fast-moving particles. Okay, you can imagine them like bullets, and this radium source was like a machine gun giving off a stream of alpha particles, these very dense, very heavy, positively charged, very fast-moving particles. So Rutherford got a couple of his students, called Geiger and Marsden, to do some experiments with this radium source, and one of them was firing alpha particles at very, very thin gold. Now, very, very thin gold, if you bash gold long enough, it gets incredibly thin, maybe even just a couple of hundred atoms thickness. And you fire alpha particles at it. Now, what you would expect is that the alpha particles would just go straight through. Because if the gold atoms are like plum puddings, then an alpha particle, if you fire a machine gun at a load of plum puddings, there's going to be plum pudding everywhere, but the bullets are just going to go straight through. I'm not suggesting you try this, but if you did it, that's what would happen. So using this apparatus, what they could do is see what happens to the alpha particles when they go through the gold foil. So the whole thing is in a vacuum, because alpha particles would only go a couple of centimeters in air otherwise. So the whole thing's in a vacuum, and you can turn this microscope around and you can see what the alpha particles do. And what they discovered was, now most of the alpha particles do just go straight through, as you would expect, but a small number of alpha particles were deflected. Yeah, they changed direction, and a very, very small number actually bounced back. And this was very surprising. Okay, a quote at the time, it's like firing a cannon at a piece of tissue paper and it bouncing back. So basically, Rutherford realized that the plum pudding model needed modifying, that atoms weren't like plum puddings. And so the plum pudding model, I can't explain this evidence. To deflect the alpha particle, you'd need something very dense and very positive. Okay, so that as the alpha approaches it, it feels a repulsive force and it is deflected. And looking at how many alpha particles were deflected and at the different angles, and if you do the maths, it tells you that whatever's doing it must be very, very, very small. So Rutherford had a big think about it, and he did the math, and he came up with a new model of the atom, which is very similar to what we think of atoms as now, at least at GCSE. So Rutherford's atom has a very small, very dense positive nucleus, and then electrons whizzing around the outside. So basically, Rutherford came up with the idea of a small positive nucleus. Now, does this explain the evidence? Yes, it does. Most of the alpha particles don't go anywhere near a nucleus, so they just go straight through. The electrons aren't going to do anything to the alpha particles, okay? So most of the alpha particles just go straight through. A small number of alpha particles do get quite close to a nucleus, and they are repelled by the nucleus because they're both positive, and there's a repulsive force which changes their path. They are scattered. If you like, this experiment is called alpha scattering. Okay, they are scattered. They change direction. And then a very small number approach a nucleus head on, and they get very close to the nucleus and then they bounce back. They don't actually touch the nucleus, okay, but they get very close and they are repelled and they come back where they came from. Okay, it's like a head-on collision. So further experiments done by Rutherford and others suggested that different elements had different amounts of charge in the nucleus, and basically the bigger the mass of the atom, so looking at the periodic table, as you go through the periodic table, the charge gets bigger and bigger. And so Rutherford suggested that the nucleus contained positive particles called protons. So this is when protons came on the scene. And then about 20 years later, this guy, James Chadwick, also did some very clever experiments that you don't need to know. And he came up with evidence for neutrons. So now we have protons and we have neutrons and we have electrons. This is very much our GCSE model of the atom. Now, Niels Bohr, he came up with a better model for the electrons, what the electrons are doing. 1913, he was working with Rutherford, and basically he suggested that the electrons can only orbit at certain distances from the nucleus. If you think about planets going around the sun, a planet going around the sun can be at any distance from the sun, as long as it's traveling at the right speed. Okay, but electrons aren't like that. Electrons can only be at certain distances. They can only have certain energy levels. And this explains spectra. In the last video, I talked a bit about spectra, the fact that atoms can absorb and emit radiation, and why can they only absorb and emit certain amounts of radiation is because the electrons can only be at certain distances from the nucleus. So that's Niels Bohr. That's as far as we get at GCSE. If you do A-level physics, A-level chemistry, we take it even further than that. Okay. However, what we've looked at is a very good example of how science works. You start with a model, then new evidence comes along and you get a better model, and then somebody thinks of an experiment to do and you get new evidence, and then you get a better model, and then somebody thinks of an experiment to do. They have a hypothesis, and then you get new evidence, and then you get a better model, and the model gets better and better. Okay, a good scientist is never disappointed if somebody proves that they are wrong. Now, why? Because at the end of the day, you're going to get a better model, and that's what science is all about. And the first scientist appreciates that and knows that they've contributed in the evolution of the model.